Okay, so let's get started. In our last lecture, this is what we talked about. This is going to be lecture number 10. So, in our last lecture, we talked about arrays, like what are arrays, how can we declare them, and how can we use those arrays. Okay, so we talked about how to initialize arrays using loops, using initializer lists, and using random numbers, of course. We did that. In this lecture, we are going to talk about these things. How can we pass arrays to functions? And once we start doing that, like we learn how to pass arrays to functions, we are going to write functions that will then sort those arrays. So it is a very important computation, sorting arrays, sorting the elements in an array into a particular order, ascending order or descending order. So this is something that is very commonly done. So we'll learn how to do that. We'll particularly talk about one algorithm that is called the bubble sort algorithm. And then we'll also look at some example in which we will try to find the mean of an array. This should be easy because we find the sum of the elements of the array, so getting the mean would be very easy. The median of the array, when you sort an array into a particular order, ascending or descending, so the array in the middle, that is the median. So how to get the median or find the median of an array. And again, finding the mode of the array, how to find the most frequently appearing element in that array. Again, mode can also be found very easily if we have a sorted array. Okay, so in that array we can find the elements that are very frequently appearing. We can find that. We'll also try to look at algorithms for searching arrays. This may not be possible in this lecture, and we might need another lecture to complete all these topics. In the end, we'll also talk about multi-subscripted array. So let's get started. The first thing is that we need to pass arrays to functions. Okay. So I hope you know what functions are, how to write your own functions, and you have been passing elements to functions. And if you remember in the previous lecture, I asked you to recall one lab task in which I asked you to find the average of 10 integer values. Now that was something difficult to do at that time because you had to declare 10 variables to store those 10 values. And here we are now, we have learned about arrays, and now we are going to write functions that is going to find the mean of those arrays. Okay, and we are not going to use 10 or 100 or 1000 arguments to that function. Instead, we are going to just pass an array to that function, and we are going to use that array to find the sum of all the elements or the mean or average of all the elements stored in that array. Okay, so that is what we are going to do. So how do you pass an array to a function? So this is how you pass an array to a function. For example, if you have this array which has, say, for example, 24 elements, and you want to pass this array to some function, let us call that function as my function, and that function needs to operate on this array. So how are you going to do that? So this is your function, and this is the array that we want to pass. We just pass it the name of the array without anything else. And as a separate argument, so this has two arguments, we pass it the size of the array. Now this is not mandatory, like it is not mandated by the compiler. The compiler doesn't say that it's compulsory that you pass the size of the array to this function. But if we want to iterate over all the elements of the array, we need information about the size of this array, because if you just pass this array to this function, my function, it does not carry the information about the size of this array or the number of elements in this array. So in order to write code that would be able to iterate over all the elements of the array, we need to pass the size of the array or the number of elements in that array as a separate argument to this function. Okay, so it is not required by the compiler or by the C++ language. It is required by our functional requirements, like we want to be able to access all the elements in the array, or we want to be able to process all the elements in the array. So that is why we need to pass the size of the array as an argument. So this is how you pass an array to a function. Okay, you just specify uh, But this is basically the function call that you would make in the main function. This is the call. Okay? This is not the prototype declaration or definition of the function. That would be a little different. So we'll look at that as well. But before that, you need to remember that arrays are always passed by reference. Arrays are always passed by reference. Why do we need to do that? Because arrays are supposed to have multiple values, and those multiple values can be in the hundreds, tens, or thousands. So it is very inefficient to pass to make copies of those values. So pass by copy or pass by value. Sorry, pass by value is not the preferred way of passing arrays. Pass by reference is the default and preferred way of passing arrays. It is much more efficient, but it has another consequence, and that consequence is that when you pass something by reference to a function, then you give that function the ability to change that value. Okay, so for example, if you look at this example, we are passing this array my array to this function. Now this function gets the ability or is able to change the elements of this array, and usually that is what we want to do. Usually that is what we want to do, and that is why we want to pass the array by reference. Okay, if you don't want this function to change the elements of this array, then you can pass it as a const reference. Okay, you can pass it as a const reference. You can do that. So functions can modify the original array data. Value of name of array is address of the first element. Okay, so this thing here, like my array, this thing, this is basically the name of the array, and it is also the address of the first element of the array. So we'll basically verify that, like the name of the array is the first address of the first element of the array. So they are the same thing. So let us verify that. Let us create a project. We are not going to just verify that, we are going to do other things as well. But let us create our project. This is going to be our second project on arrays. So let us call it as arrays second. Okay. Okay. So first of all, uh, let us create an array. Let it be an integer array, and let us call it as int ar, or yes, int ar, and this is an integer array. Okay, so it has these many elements, say 10 elements. Okay, so the question is, what happens when you say cout arr int is equal to arr int? Okay, so what would print if you print just the name of the array? Okay, what would happen if you just print the name of the array? Similarly, we also want to do something else, and that is we want to print address of the first element of arr int. So this is an array, and we want to print the address of the first element of this array. For that, we use the address of operator. So this ampersand is the address of operator. Okay? This is the address of operator. I hope we have talked about it before. Say for example, we have this variable x, okay, and x has some initial value 10. This is not necessary, but in any case, so you can print x. You can say x is equal to, and then the value of x. Okay, and you can also print the address of x. Like every variable that you have, it is allocated some space in RAM, and it has some address there. Okay, some numeric value that basically can be used to access this variable. So address of x, how do you get the address of x? So the address of x is ampersand x. Okay, so this basically gives you the address of x. This is x. Okay, so when you just say x, it would print the value of x. When you say ampersand x, it would print the address of x. Okay, so it would be some hexadecimal value. We'll look at it. So let us compile this code and then look at the output. Okay, what is it saying? Return 0. So we are doing something wrong. Okay, so we didn't complete this statement. That's why we have this error. So here we wanted to print the address of the first element of the array int. So what is the first element of array int? It is arr int. This is the name of the array, and the first element of the array is at index 0. Okay, we don't want to print the first element of the array. If we wanted to print that, this would have been fine, but we don't want to. We want to print its address. So that's why we need to apply the address of operator. So address of the first element of array int. That is what we want to print. Okay, that is what we want to print. Okay, so let's see how does this code behave. Let us look at the output. Okay, it compiles fine. Let us build and run it and then see what happens. Now look here. We have this variable x, its value is 10. When we say cout x is equal to 10, so this is what we get, x and the value of x. This is the first line. Okay, x is equal to and the value of x, so 10. Then we say address of x. So x is just any normal variable. It has the value 10, but here we want to print the address of x, in the random access memory. So you can use the address of operator to get the address of some variable. Okay, so x is a variable and we apply this address of operator to it and we get its address, and that is what is printed here, 61FDEC. This is hexadecimal value. Hexadecimal is base 16. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits from decimal and 6 more hexadecimal. So those 6 more digits, they basically come, we borrow symbols for them from alphabet, the English alphabet. So A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. Okay, so this address, it ends up in C, which is 13. C is 13, A is 10, B is 11, C is 12, sorry, 12. Addresses are usually even, usually. Okay, so this is 12. Now, the next thing that we want to print is, we just want to print the name of the array int. This was not like important. We did it just to demonstrate, like I am forgetting that whether we have talked about the address of operator or not. So that's why these two statements are here. You can apply the address of operator to any variable and get its address. Okay, this is important when we are talking about pointers. This is what we are going to do very often. So this you can do, and this was not the point of this particular discussion. The point of this particular discussion was like what is stored in this variable array int, simply the name of the array. So if you just print the name of the array, if you say cout array int, so you're not going to get all the elements of array printed on the screen. What you're going to get is just the address of the first element of the array printed on the screen. Why? How is this the first address of the first? So we verify it. We access the first element of the array and we apply the address of operator to it. So that basically gives us the address of the first element of the array and we print it on the screen. Okay, so both these values are the same. So whether you print the name of the array or you print the address of the first element of the array, you get the same thing. So what it means is this, the name of the variable that basically is the name of this array, it stores the address of the first element. It stores the address of the first element, and that address basically allows you to create to determine the addresses of the remaining elements of the array. Okay, how? Now this is an integer array. Okay, this is an integer array and it has 10 elements. Now this is the first address of the first element of the array, 61FDF0. The address of the second element of the array would be 4 more than this. It would be 61FDF4. the address of the next element, the second element, the third element would be 4 more than that, 61FDF8, and after that it would be 61FDF12. 12 is C in hexadecimal, so it would be FC. You can verify that. Okay, so if you print the addresses of all these elements, you can verify it. So let us do that, just to make just to take this point home. Like, so this is the address of the second element. Address of the second element, what would it be? It would be address of this thing. Then the address of the third element. So all these addresses would be like would differ by 4 from each other. Why? Because this is an integer array, and every integer takes 4 bytes in RAM. So, and if those integers are all located contiguously or consecutively, so difference between their addresses is going to be 4 bytes. Okay. So this is the third element. So you can verify that these addresses differ by 4 each, and this is how you can like generate. So it is F0, F4, F8, and then FC. Let us do that as well. So this is going to be 3. This is the fourth element of the array. Let us build and run it. Okay, so FC. So all these elements, they are spaced 4 bytes apart. Okay, so this is the first element at F0, second one is at F4, F8, FC. So what you must remember is that this variable array int, it stores the address of the first element. When you pass it to a function, when you pass an array to a function, you are basically passing the address of the first element of that array to that function. Now the function knows the address of the first element of the array, but it does not know the size of the array, so it cannot calculate the address of the last element of the array. Okay, that is what it needs to do. It needs to be able to access all the elements in the array. So that's why it is important that you pass size information to the function as well whenever you are passing an array to a function. Okay, so let's get back to our discussion here. So value of name of array is address of the first element. Okay, so function knows where the array is stored, so it has the address of the first element, and if you pass it on the size information, it would also know like where are the successive elements of that array, and up until which location does that array go. So it can access all the elements of the array, and it can change the original manual locations. Okay, so you can pass arrays by reference. You can pass an entire array to a function by reference, or you can write functions that only operate on integer values, and those integer values can be or can be individual elements of an array. So you can pass individual elements of an array by value, just like other variables. Okay, so if you have written the square function, you can pass individual elements of that array of an array to that function one by one, and that passing of elements of array would be by value. It won't be by reference, because you're not passing the entire array, you're passing individual elements of the array. So this is how you write prototypes of functions that are going to operate on arrays. Okay, so if you want to write a function, say modify array, which is going to operate on some integer array, so this is how you can write the the prototype. So in this particular prototype, we not only do we mention that this is going to be an array, we also give it a dummy name. So this is an array, integer array B, and this is the size of that array. You can also write this prototype as this, like you can specify that it is going to receive an array and another integer value, which can be anything, but we are going to pass the size of the array here. So as you know, I guess I mentioned it in one of my previous lectures that names are optional in prototypes. Like when you're writing function prototypes, these names are optional. Sorry, this is just name. The name is just B. This is not name. This basically specifies that you're passing an array. So similarly, these names are optional. These are dummy names. These are not going to be used in any way. You can, when you're defining this function, you can change these names and you can specify other names. So the prototype of a function which receives an array can be any of, you can write it any of these ways. Okay. No need for array size between brackets. You don't need to, if you're passing one dimensional array. This is a one dimensional array or a single subscripted array. It has just one dimension. It is either a row or a column. You can interpret it as a row or a column of values. It is not a table of values which has rows and columns. We'll talk about that later. So if you are working with one dimensional arrays, then you don't need to specify the size in the prototype. Okay, what should be the size here? Okay, you don't need to specify that. But if it is multiple subscripted array, then you need to specify the size for at least one dimension. Usually that is the second dimension or the second subscript. We'll talk about that when we talk about multiple subscripted arrays. But right now, this is what it is. Like, you don't need to specify the size here in the prototype. Okay, it is, if you, even if you specify it, the compiler ignores it. You can change it. That means you can change it later on. If array parameter is declared as const, if you declare this array as const, if you say const int array, then this function won't be able to modify this array. Okay? This function will not be able to modify this array. If it tries to modify this array, then you'll get a compile error. You'll get a compile error. So const references are useful when you're trying to write a function that you don't want to modify the argument which has been passed to it by reference. Okay, so the same applies for arrays as well. They are passed by reference by default. If you want a function not to be able to change that array, then pass this array as a const. Okay, so then it won't be able to change it. Okay, so we are going to write, first of all, we are going to learn how to pass an array to a function. Let us do that. Okay, and then we are going to talk about sorting arrays. So first of all, if you remember, like in the previous lecture, we did some tasks that were related to initializing arrays and printing arrays. Okay, so let us write those functions here. Let us write that code as separate functions. Okay, so we are going to write a function that will initialize an array. So let us call that function as init array. So void init array. So the purpose of this function is that it would initialize an array, and it is not going to return any value. Okay, so that's why it is returning void. So it's going to get two arguments: one, the array, an integer array, and we don't want to pass it as a const because the job of this function is to initialize that array. So we want it to change the value. Okay, so it should not be const. The second is an integer value that would be the size of this particular array. Okay, actually, the next function that we want to write is we want to write a function that would print an array. Okay, now print array, we don't want the print array function to modify the array, so we can declare this argument as const int. Okay, because we just want it to read the values and print them on screen. We don't want them to modify those values. Okay. Okay. So let's. I don't know how do we want to initialize the values, but I guess it is easy to initialize the elements of an array using random numbers. Okay. So let us include the library that would allow us to use the random function. C standard library, and let us include the library that would allow us to change the seed of the random number generator so that every time it generates a unique sequence. Okay, so let us first uh, change the seed of the random number generator, and we did it last time using this technique. So We call the srand function. It changes the seed of the random number generator, and we pass it the value of the time function, which is basically the number of seconds since 1st January 1970. Okay. So this is we need to do it once at the beginning of the program, and then we don't need to worry about it later on. Okay. Acha, we want to get rid of this thing. This code is no longer required, so I'll simply comment it out using a C style comment. Okay, let us try define these functions. So the first function is for initializing the array, the second one is for printing the array. Okay. So here let's say we will get the array in the variable say arr or arr say x, let us call it that, and here we will have size in the variable sz. Okay. Achha. Similarly here also we'll have size, and let us call this as constant arr x. Okay. Okay, so let us initialize it. So how do you initialize in elements of the array? So what you do is you write a loop. That loop starts with the first element of the array, which is at index 0. So I is going to be our index, and we'll use this index to access individual elements in the array. I should go up until size minus 1. Okay, so you can either write it as I is less than or equal to size minus 1, or you can write it I is less than size. So it will, the maximum value that it will have is size minus 1, and then plus plus I, increment I. Okay. Here what we are going to do is we are going to assign the ith element of this array x this value. What is the value? We are going to call the rand function. The rand function is going to give us values between 0 and 32,767, but we want to modify it. We want to scale it down to say 0 to 99. Okay, that is what we want. So we are going to get values between 0 and say 99. So if that is what we want, we need to say rand modulo 100. So now we are going to have values between 0 and 99. Okay. So this function will initialize an array that we pass it here. Now the name of this array and the array that we have here, these are different, but it doesn't matter. This array, this array here, it would be an alias of that one. When you change this one, you are basically changing the array in the main routine. The next thing that we want to do is we want to write this print function. Okay. So the print function, what it's going to do is it's going to access all these elements and it's going to print them. And let us print them in a row, a single row. Okay. So let us do that. So we want these elements to be printed in a single row. So the first element, and then followed by a comma and a space, and then the next element, then comma, then the next element. And once we are done, let us print an end line character. Okay. So the next printing will take place on a new line. So these are two functions. The first function will initialize an array with random values between 0 and 99. The second function, print array, will print that array. Okay, so it will make our job very easy. So let us initialize this array. So how would we initialize it? We'll call the init array function. We'll pass it this array int and its size as well. So right now size is defined as, let us define it as const int array size. Okay, it is equal to say 10 right now, and let us create array based upon the size, and let us pass this as an argument. Okay, so this would initialize the array, and then let us print this array, print array. So print array would also get these two same arguments. Okay, and let us print these messages. Okay, cout. First we want to initialize the array, initializing the array with random values. Okay, and next is printing the array. Okay, printing the array. And this is initializing the array. So let us build and run this code. Let us compile it first and then build and run. So here you can see first we initialize the array with random values, and of course we didn't do, like, during initialization we were not printing those values, and then we printed the array. Okay? So the array has these values 42, 90, 83, 64 and all that. Now see, we can print the array before initializing as well. Okay? Uh, so let us print the array before initialization, so we know like what initialization did to this array. So this is the array with garbage values. Okay? So let us print that message as well. So this is the uninitialized array. The uninitialized array. Okay? Let us build and run it. So this is the utility of functions. Like, we have this function print array and we are calling it as many times as we wish. If we did not have this function, then we would need to rewrite this loop again and again as this loop. If we wanted to print the array, so we would need to rewrite this loop over and over again. But the beauty of functions is that we have written it once and then we can call it as many times and any way that we want. Okay? So first we are printing the uninitialized array, then we are initializing it with random values, and then we are printing it again. So let's look at the output. So this is the uninitialized array. These are garbage values. Okay? Then we pass the array to this function init array. We pass it this array, the one that we have defined, declared in the main program. Okay, so the init array function receives it in this variable arrx. So arrx is basically an alias or another name for this array. It is an alias or another name for. So it is another name for this variable, this array that we have. When we are changing this array here inside the init array function, basically we are changing this array here in the main function, because this array is passed by reference. This array is passed by reference. Okay, so when it is passed by reference, so this here, it acts like an alias for that array. This here acts like an alias for the array in the main function. It acts like an alias for the array in the main function. So when you change it, when you change it when you change it here in the init array function, you're basically changing the array in the main function. This array in the main function, you're basically changing that. Okay? That is what pass by value, pass by reference means. These are the implications of pass by reference. Now in the print array function, and that you can see, like, after the init array, the array that we have, it has these new values, these random values chosen between 0 and 100. So between 0 and 99, all these values that we have, those values are here in this array. Okay? It has been initialized with these values. Now the print array function, it receives the array which is by default passed to it by reference, but here we have specified that this reference is const, so that means we cannot change it. Here we are not changing it, but even if you try to change it, for example, if you say array x is equal to the say for example, let us do it inside the loop. Here, say for example, if you want to say something like the ith element of array x is equal to 0, say for example, this the compiler will flag an error here. Why? Because you're trying to assign a value to a constant reference. You're trying to change a variable that has been passed to you by a constant reference. So we cannot do that. Okay? We cannot do that. So let us build and run. This is how this code basically works. And this is how you can pass an array to a function. Okay. So this is how you write the prototype for that function, and this is how we are passing it by default as reference, and this is how we are passing it as a const reference. Okay. So arrays are passed by default by reference. Achha, when you're passing a single subscripted array or a one-dimensional array, you don't need to specify the size here in the prototype. That will change a little bit when we are dealing with multiple subscripted arrays. Okay, so in that case, then you will need to pass on the size of at least one dimension. Okay, so we'll talk about that later. Okay, so up until now, like we've talked about passing arrays to functions and how that works. Okay, the next thing is that uh, one very important computation that we perform on arrays is sorting. So we want to sort arrays, and we want to do it in say ascending order or descending order, and it happens in almost every application. So say for example, this is Windows Explorer. Now, if you see here, these are different files here in this particular folder, and these are its different attributes. So you can sort these files based upon these attributes. If I click on say date modified once, so it will sort the files and folders in this particular folder based upon the date modified. So I have the latest file at the top at first, and then a file slightly older than that, and then older, and then the oldest file. This is the oldest file, say. If I click upon it again, so the order will change. Okay, so now it is say the oldest file is at the top and the latest file is at the bottom. Okay, so this is the operating system. Like even in the operating system, this is how it works. You can sort different the contents of different folders in different ways, and this works in almost anything. If you go to Google and search something, so the at the very top, the results that you get, those are the most relevant results. So the results are sorted in some way. So sorting is a very important computation. Here we are going to look at a very basic kind of sorting algorithm, and that sorting algorithm is called the bubble sort. Okay, it is called the bubble sort. So one sorting is very important for computing. Virtually every organization must sort some data. It needs to sort some data. If we have to compile your merit list, we need to sort your GPAs. Okay, if we need to find out the seniority list of the employees of an organization, that also involves sorting. Okay? If the board of intermediate and secondary education, Peshawar, or the federal board, if they need to generate a merit list, so they need to sort the result of thousands of students. Okay, so sorting is a very important computation. We'll talk about this one algorithm for sorting, that is bubble sort. It is also called sinking sort. Okay? So bubble sort means values can bubble through the array to the top, or they can sink to the bottom of the array. Okay, so it depends upon like what are we doing and how are we doing it. So how does bubble sort work? We'll look at an example and then we'll see how does it work. But bubble sort, uh, this algorithm sorts an array in several passes. Like in order to sort the array, you have to go through elements of the array more than once. Okay, you have to go through more the elements of the array more than once, And how do you do it? The way you do it is that you compare two consecutive elements, and if those two consecutive elements are in a particular order, in the required order, you do not swap them. If they are not in the required order, then you swap them. Okay. So we'll see what does it mean. Okay. Acha. And this basically process is repeated for all the elements in the array, and it is repeated like more than once. So we look at an example and then hopefully you understand. So look at this example. Say this is the array that we want to sort. Okay. So say the array starts from left to right. Like we want to sort it in the ascending order. Ascending order means that at the leftmost position we should have the smallest value, and at the rightmost position we should have the largest value. Okay. So on the left we should have a smaller value, on the right we should have a larger value. So this is the original array. Now we are going to sort it that way. How are we going to do it? So the way this algorithm works is it says that you should look at just two values. Like you start from these two values. This is the original array. You start and look at the first two values. So is the smaller value on the left and the larger on the right? Yes, it is. So you don't change this pair of values. Okay? Okay. Then you go and check the next pair. Okay? The next pair is this 4 2. We check 3 4. The next pair is 4 2. Now look at 4 2. Are these two elements in the correct order? Is the smaller on the left and the bigger on the right? No. The bigger is on the left and the smaller is on the right. That means you need to swap these two elements. So 2 should come to 4's place and 4 should come to 2's place. So this is how we swap these two. Okay, this is the swapping. Next is this pair of elements. Are these two in the right place? The smaller is on the left and the bigger on the right. Yes, so we don't need to do anything about it. Next is these two elements. Are these two in the right order? Smaller on the left, bigger on the right? No. So that means we need to change these two elements. So 6 comes to 7's place, 7 goes to 6's place. So after pass 1, this is how the array would look. After pass 1, this is how the array would look. Now if you look at it after this pass, the smallest value is not in its correct position but the largest value. It has sunk to the bottom. The largest value is 7. It has sunk to the bottom. Okay. Now we have to work on this array in the second pass. So the second pass starts with by looking at the first two elements in this array, which is the result after pass 1. So are these two elements in the correct order? No. Why? Because 2 is smaller, it should be on the left, and 3 is bigger, it should be on the right, but they are not in the correct order. That means we should swap these two. So when we swap these two elements, this is what we get. 2 is comes to 3's place and 3 goes to 2's place. Then look at this pair. Are these in the correct position? Yes, 2 is smaller, it is on the left, 4 is on the right. Then this pair, 4 and 6, are these in the correct order? Yes, 4 is on the left, 6 on the right. Then 6, 7, are these in the correct order? Yes. We don't need any exchanges here. So there was only one exchange, and that was of 2 and 3. So after the second pass, if you look at the array, it is pretty much sorted. Okay? But we don't know like whether it is sorted or not because the computer cannot see all these values. So the computer would, and if you see like the next largest value 6, it has sunk to the bottom to its correct position. So now 6 and 7, these are in their correct positions. Okay? Now pass 3 would start working on this array. It will start with the first pair 2, 3. Does it need exchange? No, the values are sorted, so it doesn't need exchange. Then 3, 4, does it need exchange? No, they are also in correct order. 4 and 6, they are also in correct order. 6 and 7, they are also in correct order. We don't need to change. So this array would remain unchanged, but we don't know if it is sorted yet or not. So we'll continue with the passes. Okay? How many passes? If an array has 1, 2, 3, 4, 5 elements, so at most it would need 5 passes. One pass for each element to be sorted. Okay? So the array is already sorted even if we repeat that process, like compare first this pair, it is sorted, then this pair, it is also sorted, then this pair, it is sorted, then this pair, it is sorted. So even if we repeat this process, there are no swaps or changes. Okay? So that's why the array would remain the same, but nevertheless we have to do these passes. After each pass, the largest value would sink to the bottom of the array, okay, to the rightmost position, and the smallest value or smaller values, they bubble to the top. So that's why, like 2, it was here at the third position. After the first pass, it came to the second position, and after the second pass, it came to the top position, first position. So that is how small values bubble to the top, and big values they sink to the bottom. Okay, so this is how bubble sort works actually. Okay? Now we'll apply bubble sort algorithm on an array, and we'll write the code for it, and hopefully that will help you learn how sorting works. Okay? Now one important operation here is the swapping of variables. So we will basically learn how to swap. This is the most difficult computation, I guess, in sorting. The rest is all these loops and how those loops should operate. So once we do that, then we will proceed to the next problem. Okay. So first we'll write code to sort an array using the bubble sort algorithm. Okay. That is what we're going to do first. Okay, so let's write a subroutine that basically would sort an unsorted array. Okay, and in order to sort that array, we'll be using the bubble sort algorithm. So let us call that subroutine as bubble sort. So let us write this algorithm to sort the array. So this would be a subroutine. It is not going to return anything. It is just going to sort the array that we'll pass it, and that we will pass to this particular subroutine. And that array, like, it has to sort, so it has to move around the elements. So we are going to pass the array like that. We are not going to make it a const reference. So it is going to be the array directly by reference. Okay. So we are going to pass the array, and we are going to pass the size of the array, these two information. And using this information, we are going to sort this array. So let us define this function. Let's come here and let us define this function. So here we are going to write the function for sorting the array, and this function is going to implement the bubble sort algorithm. And we explained the bubble sort algorithm. So what does the bubble sort algorithm do? What it does is that it starts with the array, and it compares two elements at a time, and if those elements are not in sorted order, it sorts those two elements, and then it goes and sorts the next two elements. Okay, so we demonstrated this by going through this dummy array, and by doing uh, the actual sorting if these elements needed to be sorted. So what we noticed there was that number one, we had to do multiple passes through this array in order to sort it. So here we did, like, I guess 5 passes, but after 2 passes the array was sorted. After that there were no changes, but we don't know, like, there can be an array where we would need all the 5 passes or all the passes to sort that array. This array had 5 elements, so we sorted it in 5 passes. That is the maximum number of passes that would be required. But an array can get sorted in less number of passes, just like in this case, it was sorted after 2 passes. Okay, so you should remember one. We have to do multiple passes through the array. So how many passes for now? Like just remember that if we have to sort an n element array, so we have to do n passes through that array. Okay, so we have to pass through that array at least n times, or at most n times. Okay, and during each pass, what we do is we start from the first element of the array, the element at position 0, and we compare it with the next element, and we see if they are in the required order. So if we want to sort this array in ascending order, so we want the leftmost entry to be the smallest and the rightmost entry to be the largest. Okay, that is what we want. So we have to check these consecutive items if they are in the correct order or not. If they are not, we need to swap them. Okay, so swapping is something that we need to do very carefully. Okay, so we'll first demonstrate swapping, and then we will talk about the other things. So once we do this swapping, then we are ready to compare the next 2 elements. Okay, so we want to know if they are in the correct order. If they are in the correct order, fine. If they are not, then we need to swap them. So we start from the element at position 1. Let me start the slideshow and then demonstrate it here. So let us get rid of some of these notations. Let me get, no, I cannot get. Okay, so let me get a pen. So say for example, what happens during a single pass, we start from the first element and we compare it with the next one, then we compare this element with the next one. So element at index 0 with element at index 1, then element at index 1 with element at index 2, then element at index 2 with element at index 3, and then element at index 3 with element at index 4. So we cannot go beyond that. Okay, so you have to remember this as well. So once we are implementing it, this knowledge would be helpful. Okay, so let's go and implement this code. So the sort array function would receive the array. Let us call that array as unsorted. Okay, unsorted. Let us call that array as unsorted, and it will also have the size information. Okay, let us call it as array size. Let us call this variable as array size. So as you know, like we have talked about it, that we need to the bubble sort algorithm sorts an array in multiple passes. How many passes? So the number of passes is basically more or less equal to the size of the array. If the array has 10 elements, so at most we'll need 10 passes to sort that array. So that means like we need to repeat passing through the array. And how many times would we need to repeat the passing through the array process? As many times as is the size of the array. Okay, so we need a loop. In simple words, we need a loop, and that loop, say for int pass, so we need to pass through this array as many times as is the size of the array. Okay, so the pass would start from, or let us make it say 1. Let us start from 1. Pass is equal to the first pass, second pass, and less than or equal to array size. Okay, so we'll make multiple passes through the array, and the variable pass will basically keep track of the number of passes that we have made through the array. We forgot to increment the loop counter or the variable pass. Okay, so this is one thing that we need to do. The second thing that we need to do, like as we explained the algorithm, the bubble sort algorithm works by sorting the array in multiple passes. Okay, so this loop basically takes care of those passes. Now in each pass, what does the algorithm do? In each pass, what the algorithm does is it starts from the element at position 0, and it goes up until the second last element. Okay, so it starts from here and it goes up until here, 7. So it will start from, say, element 3 and it will go up until element 7. 7 is it at index 4, sorry, at index, yes, 0, 1, 2, 3, at index 3 here, which is size minus 2, which is size minus 2, I guess, yes. So the size of this array is 5. The index starts from 0 and it goes up until 4. But when we are doing a single pass of the bubble sort algorithm, so what we do is we start from the element at index 0 and we go up until the second last element in the array, and each time we compare it with the next element. Like we compare this element 3 with 4, we compare 4 with 2, we compare 2 with 7, we compare 7 with 6. That's it. Okay, so the second loop, what it does is it starts from, say, I is equal to 0. In each pass it starts from I is equal to 0 and it goes up until I less than or equal to uh, array size minus 2. Okay, why array size minus 2? Because the index of the array, it starts from 0 and it goes up until array size minus 1. So in the index of the last element of the array is array size minus 1. The index of this element 7 or this element 6 here, for example, in the original array, its index is array size minus 1. Array size here is 5. So 5 minus 1 is 4. So the index of 6 is 4, which is array size minus 1. And the index of the second last element is 3, which is 5 minus 2, or array size minus 2. Okay, so I would go from 0 in each pass. I would go from 0 to array size minus 2. And what are we going to do during each pass? During each pass, we are going to compare the two elements together. Which elements? So we are going to compare if unsorted I, the ith element in the unsorted array, if it is, say for example, greater than, we want to sort the array in ascending order. So if the ith element in the unsorted array is greater than the I plus first element, the next element. Okay, so look here. So we are going to compare, say, this element with the next element. So if this element is at index I, this element is at index I plus 1. Okay, this element is at index I plus 1. Let me repeat that again. So we are going to compare, say, for example, this element 2 with the next element 3. If 2 is at index I, then 3 is at index I plus 1. So each time we are going to do this comparison starting from 2. So once we do this comparison, if this element is less than this element, we don't do anything. If this element is greater than this element, then we need to swap. Okay, so that the smaller element, it comes to the left and the larger element, it goes to the right. Okay, so if the ith element is greater than the element at position I plus 1, the next element, then we need to do swapping. Okay, so then we need to do something that we call swap. If that is not the case, then we don't need to do anything. If that is not the case, then we don't need to do anything. Now, how do you do swapping? Let me show you here in the main program. Okay, how do we do swapping? So, say for example, let us comment this code out. Uh, Let me comment this code out as well. We first need to demonstrate swapping. Okay, say for example we have two variables, int a which is equal to 10 and B which is equal to say 15. Say we have these two variables. Okay? We want to swap them. What do we mean? We want to copy the value of B into A and the value of A into B. That is what we want to do. That is what swapping means. Copy the value of B into A and the value of A into B. Adli badli karna. Okay? Butta satta. So that is what we want to do. So let us print the values of A and B before swapping. Okay? So before swapping. Before swapping. See out, say A is equal to and then A and then comma B is equal to and then B. Okay? So these are the values of A and B before swapping. Now we want to do swapping and then we want to print these values after swapping. अच्छा, how do we do swapping? So हमने A की वैल्यू B में कॉपी करनी है, B की वैल्यू A में कॉपी करनी है. So maybe आप सोचेंगे जी let us do A is assigned the value of B and then B is assigned the value of A. ठीक है? तो अदली बदली हो गई. ठीक है? अच्छा, let's see if it works. इसके मुताबिक if it works, if this swapping works, then A after swapping A should be 15 and B should be 10. ठीक है? If it works. अच्छा जी, let us build and run this code. ये क्या कह रहे हैं जी? For अच्छा ये int I, this should be declared int I is equal to. अच्छा जी. अच्छा जी, say build and run. So before swapping A is equal to 10, B is equal to 15. After swapping A is equal to 15, B is equal to 15. ठीक है? तो इसका मतलब है कि swapping नहीं हुई. B should have been 10, but B is 15. So that means there is some problem. We are doing something wrong. ठीक है? क्या गलत कर रहे हैं? Let us see. अच्छा, what we want to do is कि हम A में B की वैल्यू कॉपी करना चाह रहे हैं और B में A की वैल्यू कॉपी करना चाह रहे हैं. This is fine. ठीक है? But problem is कि when we copy the value of B into A, then we lose the value of A. A में फिर B की वैल्यू आ जाती है वो कि 15 है. तो अब A भी 15, इस स्टेटमेंट की एग्जीक्यूशन के बाद A भी 15 हो जाएगा, B भी 15 है. ठीक है? और फिर अगर आप कहते हैं कि B इज इक्वल टू है तो आप बेसिकली B में B की अपनी और दूसरी जो वैल्यू है वही कॉपी कर रहे हैं. तो B इज इक्वल टू A ऑलरेडी 15 है, तो 15 इज इक्वल टू 15 यानी B में आप 15 दोबारा से असाइन कर रहे हैं. सो दैट इज द प्रॉब्लम. लाइक जब आप कहते हैं कि A इज असाइन द वैल्यू ऑफ B, यानी A में आप B की वैल्यू कॉपी कर रहे हैं, तो यू लूज द वैल्यू ऑफ A की वैल्यू ओवरराइट हो जाती है, यू ओवरराइट 10. ठीक है? एंड देन व्हेन यू से B इज इक्वल टू A, so what you do is A की जो नई वैल्यू है that is 15 which is the value of B, so you are just copying that value back into B and that does not make any difference. ठीक है? उससे आपको कोई फायदा नहीं हो रहा, दोनों में वही वैल्यू है. So what should we do? ठीक है? So what we should do is before overwriting the value of A, we should save it in some temporary variable. Okay? So let us declare a variable temp. Acha. So before you do something like A is equal to B, yeah, A is assigned the value of B, you should do temp is assigned the value of A. Store the value of A. Store the value of A in a temporary variable. Then assign the value of B, copy the value of B into A. अब इसके बाद B में A की वैल्यू कॉपी करने की जरूरत है. तो A की वैल्यू कहाँ है? वो आपने यहाँ पे टेम्पररी वेरिएबल में स्टोर की थी. So you can get that value from a temporary variable. Okay, so this is how swapping works. This is how swapping works. Now if you compile this code and build and run it, so now swapping will take place correctly. ठीक है? So before swapping A is 10, B is 15. After swapping A is 15, B is 10. So this is what we mean by swapping. A और B ने आपस एक दूसरे में वैल्यू एक्सचेंज कर ली. ठीक है? वट्टा सट्टा हो गया. लेकिन in order to do this properly, you need a third variable, a temporary variable. ठीक है? Now that is what we need to do here. यहाँ पे यही काम हमने करना है. ठीक है? So we need a temporary variable. So let us declare that in temp. Let us initialize it to the value 0. ठीक है? अच्छा, हमने यहाँ पे क्या करना है? Here we see कि at the ith position we have a value which is greater than the value at the I plus 1 position. चूंकि हम अरे को सॉर्ट करना चाह रहे हैं इन असेंडिंग ऑर्डर. ठीक है? सॉर्ट असेंडिंग. वी वांट टू सॉर्ट दिस अरे इन असेंडिंग ऑर्डर. ठीक है? तो इसका मतलब ये कि ith पोजीशन पे वी शुड हैव अ स्मॉलर वैल्यू, नॉट अ बिगर वैल्यू. एंड इफ वी हैव अ बिगर वैल्यू एट ith पोजीशन वी नीड टू स्वैप इट विद द नेक्स्ट वैल्यू. ठीक है? दैट इज व्हाट इट इज. ठीक है? सो हाउ डू यू डू द स्वैपिंग? हमने unsorted I और unsorted I plus 1 को swap करना है. How do you do it? So first store one of these values in the temporary variable. So say हम unsorted I को temporary variable में store कर लेते हैं. Then you can begin with the swapping. So now we have a copy of unsorted I, so we can overwrite it with the value at I plus 1 position. Okay, and now we can write that the value that we stored in the temporary variable, we can write that value in the I plus 1 position. Okay, so this is how sorting would take place. So do not get confused with these indexes, and because they are elements of array, consider them as normal variables a and b. यहाँ पे अगर आपको, if you can understand it here, you should be able to understand it here. So these are the values that we need to swap. So before you start swapping, you should store one value in a temporary variable. जिसको store किया है, you can override that variable with the one with which you want to swap it, and then you should जिसको swap कर दिया है to ith position पे, you can override it with the value of the ith position जो कि हमने temporary variable में store की है. ठीक है? So this is how swapping would take place. ठीक है? This is what it is. This is the whole algorithm. You look at two values at a time. If those values are not in the required order, ascending order in this case, you swap the values so that they are in the correct order. Then you move to the next two values. ठीक है? So I is equal to 0 से start ले रहे हैं, तो हम 0 और 1 इंडेक्स पे जो वैल्यूज है पहले उनको कंपेयर करेंगे. फिर I2 हो जाएगा, 1 हो जाएगा सॉरी, तो फिर हम 1 और 2 इंडेक्स वाली वैल्यूज को कंपेयर करेंगे. फिर I2 हो जाएगा तो 2 और 3 को कंपेयर करेंगे. और I कहाँ तक जाएगा? अरे साइज -2. तो अरे साइज अगर 10 है फॉर एग्जांपल, तो ये 10 - 2 8 तक जाएगा. सो वील बी कंपेयरिंग the last iteration of this loop will compare say array element at index 8 and 9, उनको कंपेयर करेगा और वहां पे अगर सॉर्टिंग की जरूरत हुई तो वो करेगा. अच्छा जी, अब यहाँ पे हम यूं करते हैं कि यहाँ पे आफ्टर ईच पास वील प्रिंट द अरे. ठीक है? आफ्टर ईच पास वील प्रिंट द अरे सो दैट वी नो कि क्या हो रहा है, हर पास के बाद क्या हो रहा है. ठीक है? So let us print the array after each pass. So after pass, so we have pass की information हमारे पास we have in the pass variable. So after say pass 1, pass 2, ठीक है? So we want to see the array. या यहाँ पे यूँ लिख लेते हैं the array after pass, and then उसका पास का नंबर आ जाएगा 1 2 3 whatever. ठीक है? So we want the output to be a new line after that, and then call the print array function. देखें print functions create करने का फायदा ये है कि you can always call that function anytime, and let us give it the array unsorted, and array size is array size. ठीक है? So after each pass we are going to print the array कि array की क्या सूरत हाल है. ठीक है? Now let's get back to the main program. अच्छा, मेन प्रोग्राम में this code was for demonstrating swapping. So let us get rid of this code. इसको हम कट कर लेते हैं यहाँ से, और मैं इसको ले आता हूँ यहाँ पे एंड पे, बिल्कुल पेस्ट कर देते हैं, ठीक है. So this was for demonstrating swapping. We don't need it right now. अच्छा जी, now come here. Let us get rid of this thing. अच्छा जी, and let us start the comment from this place. So what are we going to do? What we are going to do is we have created an array. We don't need to print the uninitialized array, ठीक है, इसकी अब ज़रूरत नहीं है. So let us get rid of this code as well. अच्छा, let us bring it here फिलहाल. So we created this array. It has 10 elements. We initialize this array with random values. So we call the init array function. It would initialize it. Then we would print the unsorted array. ठीक है. Let us call it the unsorted array. Unsorted array. So we are printing the unsorted array. In fact, we don't need to print this message either. ठीक है. अच्छा, we have initialized the array. We print the unsorted array, and then we call the bubble sort function to sort this array. ठीक है. So we call the bubble sort function and we pass it this array. वो array क्या है? It is this array of integers. And what is its size? ARR size. ठीक है. This is its size. And then the bubble sort algorithm will do whatever it has to do. So let us compile this code. The code has compiled fine. Let us build and run it. ठीक है. So this is how it works. Let's see. Let us explain the bubble sort algorithm again here. So this is the unsorted array. It has all these random values. Now we have to sort it in ascending order. That means we should have the smallest value here. Okay? And the smallest value happens to be 9. So 9 has to get here, and the largest value has to settle here. The largest value happens to be 90. Now when this algorithm starts executing, so you will see after the first pass, the largest value will sink to the bottom. This is called a sinking sort as well. So after the first pass, the highest value would sink to the bottom, and the smaller values, they would bubble to the top. So see, 9 was here at position number 4, say, or at index number 3. If index starts from 0, this is 0 index, 1, 2, 3. 9 was here up before in the unsorted array. After the first pass, 9 has bubbled up to the top. Okay? And after the second, it bubbles even more. After the third, it is at the top. Okay? After the third pass, it is at the top. And after the first pass, the largest value, it has sunk to the bottom. 90 has sunk to the bottom. After the second pass, the second highest value, it sinks to the bottom. After the third pass, the third highest value, it sinks to the bottom. Then the fourth highest, then the fifth highest, then the sixth highest, then the seventh highest, then the eighth highest. Okay, and then the ninth is already then the ninth highest. Okay, so I guess we need 9 passes to sort this array. Okay, so 9 passes are required to sort this array. It has 10 elements. In the 10th pass, we don't do anything, so everything is in order. Okay? Now, how does it work? How did we program the algorithm? So, one, we wrote 2 loops. The outer for loop has to execute for 10 times, once for each element of the array. So this array has 10 elements, it would execute 10 times. We will have 10 passes, pass 1, 2, 3, pass 10. So this statement is the array after pass 10. So this is printed in the outer for loop. Okay. So this is the result of one execution of the outer for loop, and in this one execution of the outer for loop, the inner for loop executes say I guess 9 times. Okay, 9 times. So it's in the inner for loop, we start from the element at position 0 and we go up until the second last element, okay, and we do all these comparisons. So what do we do? So first we start from element at 0. We start from 74, compare it with 36. Is 74 greater than 36? Yes, it is. So we need to swap these two. So we swap these two. Okay, so 36 comes here and 74 goes here. Okay, then we compare this 74 with 86. Is 74 greater than 86? No. So 74 remains in this position and 86 also remains in this position. We don't need to do swapping. Then we compare 86 with 9. Is 86 greater than 9? Yes, it is. So we need to do swapping. So we swap these two. We swap 86 with 9. So 9 gets here and 86 is moved to this position. But you don't see 86 here. Why? Because in the next like iteration of the inner for loop, we compare 86 with 67. So is 86 greater than 67? Yes, it is. We need to do swapping. So 67 comes here, 86 goes to this position. But you don't see 86 here. Why? Because we compare in the next pass, in the next iteration of the inner for loop, we compare 86 with 34. Is 86 greater than 34? Yes, it is. So we swap. We move 34 here, 86 comes here. But you don't see 86 here. Why? Because in the next iteration of the inner for loop, we compare 86 with 63. Is 86 greater than 63? Yes, it is. So we do the swapping. 63 comes here and 86 goes to the next position. Now here, is 86 greater than 90? No, it is not. So we don't swap it. Is 90 greater than 62? Yes, it is. So we swap 90 with 62. So 90 comes here, 62 moves here. But we don't see 90 here. Why? Because we compare 90 with 30. Is 90 greater than 30? Yes, it is. So we do the swapping. 30 comes here, 90 settles in the bottom, and then we stop. So this is how the first iteration of the first pass of the bubble sort algorithm works. The second pass starts with this array and it starts comparing these two elements. Are these in the correct order? Yes, they are. 36 is not greater than 74, so we don't touch them. Is 74 greater than 9? Yes. So do the swapping. 74 goes here, 9 comes here in this position. But you don't see 74 here. Why? Because we compare it with 67. It is greater than 67, so we swap it with 67. Then we compare 74 with 34. It is greater, we swap it with 34. Then we compare with 63. It is greater, we swap it with 63. Then we compare with 86. It is not greater than 86, so we don't swap it. So it remains here. Then we compare 86 with 62. It is greater, so 62 it is swapped with 62. Then we compare 86 with 30. And it is greater, so we swap it with 30. Then we compare 86 with 90. It is not greater, so we do not touch it. Okay? So this is the second pass of the bubble sort algorithm. This is how like you can look at how this algorithm works pass after pass after pass, and then you'll find out like how does it sort the array. Okay? So this is how the bubble sort algorithm works. Now, this particular version of the bubble sort algorithm, it sorts an array in ascending order. But this is not necessary, like you may need to sort an array in descending order. Now, this is a question for you to ponder, like what should you do to this particular bubble sort algorithm so that it can sort an array in the descending order, so that it can sort an array in the descending order. So you should think about this question. Okay, so this is, I leave it as an exercise for you. Okay, so we did the sorting using the bubble sort algorithm array. Now again, bubble sort is not the only sorting algorithm. There are plenty of algorithms for sorting, and bubble sort is perhaps the simplest and maybe one of the most inefficient ways of sorting an array. But in any case, you should know how it works and you should be able to implement it. Okay. So I did one simple implementation of the bubble sort algorithm for you, in which like we learned how to use this algorithm to sort an array in the ascending order. So you can make changes to it so that it can sort an array in the descending order. You can do that. Here we can change the size of the array as well, and it would work equally well. Let us make it say 20. ठीक है, we change the array size 20 and let us build and run this code, and it will correctly sort a 20 element array. So if you look at this array, this is a 20 element array, and at the top we have 19. This is not the smallest, I guess, is 5. Okay, so 5 needs to be at the top, and the largest value is, I guess, 95. This needs to go to the bottom. Okay, so after the 20th pass, hopefully after the 20th pass, it is guaranteed that this array would be in sorted order. But before that, that can happen before that as well. So if you look here, I guess, after the 17th pass, in fact after the 6th, yes, after the 17th pass, so it is sorted. Okay, after the 17th pass it is sorted. Now there's another question for you. How would you know, is there any mechanism for the bubble sort algorithm to know an array is sorted? Okay, so you should also think about this question as well, कि bubble sort algorithm को क्या पता चल सकता है कि array sort हो गया है या array already sorted हालत में है. ठीक है, फॉर एग्जाम्पल यहाँ हमने बबल सॉर्ट एल्गोरिथम को कॉल किया. द बबल सॉर्ट एल्गोरिथम हैज सॉर्टेड द array. ठीक है, एंड लेट अस से दैट array इज द अनसॉर्टेड array. लेट अस से वो जो हमारा सॉर्टेड array है ना, लेट अस कॉल दैट array एज द अनसॉर्टेड array. यानी मैं यहाँ से दोबारा से इस कोड को एग्जीक्यूट करना चाहता हूँ. ठीक है, लेट मी गेट द नंबर ऑफ एलिमेंट्स टू 10. मेरी बात समझ आइए. व्हाट आई वांट टू डेमोन्स्ट्रेट इज कि मैं बबल सॉर्ट एल्गोरिथम को एक सॉर्टेड अरे पास करना चाहता हूँ, एंड आई वांट टू सी कि बबल सॉर्ट एल्गोरिथम उस सॉर्टेड अरे के साथ क्या करती है. तो अभी जो इसकी करंट इम्प्लीमेंटेशन है उसमें हमने ऐसी कोई प्रोविजन नहीं रखी कि बबल सॉर्ट एल्गोरिथम वुड नो कि इफ द अरे इज ऑलरेडी सॉर्टेड और नॉट, एंड it should not sort an already sorted array. So we have not provided this provision here. ठीक है, सो क्या ऐसा मैकेनिज्म हो सकता है इस कोड में कि वी वुड नो कि द array is already sorted and we don't need to sort it any further. That is what we want to do. So उसको करने के लिए मैं क्या कर रहा हूँ, मैं एक अनसॉर्टेड array ले रहा हूँ, पहले उसको सॉर्ट करता हूँ, फिर उसको कहता हूँ कि दिस इज माय अनसॉर्टेड array, और उसको फिर मैं पकड़ाता हूँ बबल सॉर्ट एल्गोरिथम को, एंड द बबल सॉर्ट एल्गोरिथम वुड वर्क ऑन द अनसॉर्टेड array एज इफ इट इज रियली अनसॉर्टेड array, जबकि वो सॉर्टेड होगी. ठीक है, सो यही आपसे कहना है कि इफ एन ऑलरेडी अरे इज ऑलरेडी सॉर्टेड. ठीक है, यहाँ पे देखें कि ये जो अरे है इसको पहले हमने सॉर्ट किया, फिर वो सॉर्टेड अरे हमने हमने उसको वी कॉल्ड इट एज द अनसॉर्टेड अरे, एंड देन वी आस्क द बबल सॉर्ट एल्गोरिथम कि इसको सॉर्ट करो. वो ऑलरेडी सॉर्टेड है, बट स्टिल द बबल सॉर्ट एल्गोरिथम इज वर्किंग ऑन इट. So can you do something about it? Can you do something in this algorithm which would basically refrain this algorithm from sorting, from first finding out whether an array is sorted or not, and then to stop sorting an already sorted array. ठीक है, so I hope कि मैंने ये question अच्छे तरीके से phrase कर दिया. I'm not sure, but in any case just look for these possibilities. This is potentially an exam question. ठीक है, अच्छा जी. Now in this slide we were talking about swapping. I guess you know कि swapping we have demonstrated कि कैसे करनी है. अच्छा, the next thing is how to compute the mean, median and mode of an array. So I'll do the mean part. ठीक है, and the median part, I guess it can also be done easily. All these things can be done easily, but let me do the mean part. Mean क्या है? Average of all elements. ठीक है, so let us calculate that. So this is the bubble sort algorithm. अच्छा, अब मैं I need to collapse नहीं contract these functions so that we see less of it. ठीक है, we don't need to see all of it. Acha, so now we need to find the mean of an array. We need to find the mean of an array. So the mean would be some double value. ठीक है, double let us call it as mean, and let us pass it an array and an integer value containing size information of the array. Okay. And let us write the prototype for the median function as well. Median of an array. Okay. So let us implement these functions. This one is easiest perhaps. Let us do it first. The other ones are also easy. Nothing is difficult. Let me contract this code so we don't see this function, and let us implement this thing. So we need to find the mean of an array. What do we mean by the mean? Mean means average. This is arithmetic mean. Okay? So in order to find the arithmetic mean, we need to find the sum of all the elements of the array, and then we need to divide it by the size. It is this simple. Okay? Acha ji. So let us do that. This is going to be an array, ARR. Let us call it as ARR. And this is going to be ARRS. Okay? Array size. Acha. So what do we need to do? We need to first find the sum of all the elements of an array. Okay? How are we going to do that? You need a loop. Okay? So double sum, and let us initialize it to the value 0. Achha. So first thing that we need to do is we need to find the sum of all the elements of the array. So for int I, this is the index, it will start from 0. It will stop at array size -1, and this is how we would modify it. So what are we going to do? We are going to find the sum of all the elements of this array. Okay? So sum is equal to sum plus, or let us use the shortcut in operator. Okay? So this is equal to ARR I. Okay? So we are basically, this is basically sum is equal to sum plus the ith element in the array. So this loop will find us the sum of the array, and here we just need to divide the sum by the size of the array and return that value. So that would be the mean. Okay? That would be the mean. Let's see if it works or not. Achha, so this is the array. We have initialized the array, and let us type the mean. Achha, let me get rid of this code as well. Okay, this is the unsorted array. Okay, so after the unsorted array, let us print the mean of the array. Okay, so cout the mean of this array is. So in order to find the mean, we'll need to call the mean function, and we'll pass it the array here, array int, and the size of this array size. Okay? And then so this is how we'll write this code. Let's compile it, and let us build and run it. Okay, so this is the unsorted array: 2, 51, 69, 62, 90, 75, 54, 85, 88, 37. So you can verify whether it works or not. So if you add all these elements and divide by 10, this is what you get, 61.3. Okay? That means the sum of all these elements is 613 divided by 10 to 61.3. Okay? So this is how the mean function would work. Now let me find the median. Okay? How would we find the median? What is median? Median से मुराद ये है कि if you have an array
For example, this is the array and all the elements of this array are in sorted order. ठीक है, this is sorted 1 2 3 4 5, and the middle value by index. So this array has 5 elements. The middle of 5 is it is basically like it's not half of 5, that is 2.5, but among 5 elements, the middle element with equal number of elements on its left and right, that is 3. Okay, so 3 is the median, that is the median position, and 3 is the median value here as well. Look at this array. ठीक है, इसमें हमारे पास 1 2 3 4 5 6 7 8 वैल्यूज हैं. अब ये सॉर्टेड पोजीशन में है. व्हाट इज द मीडियन हेयर? सो अब ये जो एलिमेंट्स की तादाद है, इट इज़ बेसिकली हमारे पास इवन है. सो इवन में मीडियन मालूम करने के लिए फिर हमारा जो दो पोजीशंस हैं उनका हम एवरेज लेते हैं. बीच वाली जो दो पोजीशन है और वो ये पोजीशन है 2 3. ठीक है, सो अब 3 इससे पहले एलिमेंट है, 3 इसके बाद हैं. 2 3 5 5 बाई 2 इज़ 2.5. सो इसकी जो मीडियन वैल्यू होगी दैट वुड बी 2.5. ठीक है. So how are you going to find the median value? Now, I want to leave it as something that you should think about, how to find the median and how to find the mode. सबसे अहम बात यह है कि in order to find both the median and the mode, you need to first sort the array. ठीक है, array को आपने किसी भी ऑर्डर में, ascending और descending, किसी एक ऑर्डर में आपने उसको सॉर्ट करना होगा. And once you sort it, then you can find the median and mode. So I'll leave this as homework for you. ठीक है, I'll post this homework on Google Classroom, so you should do it. You should do it. ठीक है, so that's it for now. Next, I guess we will talk about. Let me see. Next, we have to talk about. Searching arrays is also, we'll briefly talk about searching arrays and then we'll talk about multi-subscripted arrays. ठीक है? For now, this is enough, I guess.